Today we're going to finish our discussion of different kinds of evidence by discussing rational and empirical evidence. First, rational evidence is evidence based on the use of reasoning. Think back to the examples of deductive reasoning that we discussed. All of those would be cases where the result of reasoning, in terms of accepting the conclusion as true or not, is used as evidence. The main strength of rational evidence is that there are rules for determining the validity of arguments through deductive reasoning. Right, we saw that there are very specific rules for deciding whether an argument is valid or not. If it's in the if P then Q, P therefore Q form, it's valid, and if the argument is also sound, then the conclusion of the argument must be true. On the other hand, other forms, such as if P then Q, Q therefore P, are invalid, and so you wouldn't accept the conclusion if the argument is in that form, no matter what. The main weakness of rational evidence is that sometimes reasoning alone isn't sufficient to determine whether a premise is true, and people often use faulty reasoning. So when it comes to determining whether the premises of a deductive argument are true, things can get murky. We might mistakenly believe that a premise is true, maybe because it's consistent with our common sense beliefs, or maybe because an authority told us that it's true, when in fact the premise is false. And later, when we discuss inductive reasoning, we'll see that there are no such rules for determining validity. And then, sometimes people just don't think things through fully. And that's going to be the focus of the next section, where we discussed various examples of faulty reasoning. The first example of faulty reasoning is illusory correlations, which is the tendency to think that two variables are correlated when in fact they co-occur at chance levels. Remember the correlation between bizarre behaviors and the full moon that we discussed last week? That's an example of an illusory correlation. People believe there's a correlation between the two variables, despite the fact that they occur at chance levels. The Barnum effect is another good example of an illusory correlation, which is the tendency for individuals to believe that general personality statements describe their unique personality. So the idea here is that people believe there is a correlation between their unique personality and the personality statements, such as from horoscopes, when instead these general personality statements describe most everyone. I posted a video on Canvas demonstrating the Barnum effect, but here's another example. Participants were given this general personality description and were asked to rate how well it described them on a scale from 1 to 5. The average rating was 4.2 out of 5, indicating that people think this paragraph describes their unique personality very well. But again, this is faulty reasoning, an illusory correlation. People think there's a link between this statement in the paragraph and their own unique personality, but remember, the statements are so general that they describe everybody's personality. A second example of faulty reasoning is confusing correlation with causation, reasoning that because two events are linked, that one of those events is causing the other. So there are a couple related reasoning errors here. One issue is confusing correlation with causation. So yes, you might have heard the phrase that correlation doesn't equal causation. What this says is that even if there is a correlation between two variables, this doesn't necessarily mean that changes in one variable are causing the changes in the other variable. We're going to talk more about this thinking error when we discuss correlational versus experimental studies in a couple of weeks. A related thinking error, though, is reasoning that if there is a causal link between the two variables, that one explanation must be true while the others aren't considered. So the idea here is that when two events occur together, that is, when there's a correlation between event A and event B, there are three basic possibilities for there being a causal relationship. Either event A causes event B causes event A, or some unknown factor C causes both events. The issue is that people often lock into one of these explanations and ignore the other two. So let's look at a couple of examples. These are the types of stories that you might hear about on the news or read about on a blog, which lock onto one explanation for a causal relationship between two variables. The first one is nightlights may lead to nearsightedness. Children who go to bed with a nightlight on in their room are significantly more likely to be nearsighted when they get older. Therefore, nightlights cause eye strain and eventual nearsightedness. Well, what are the possibilities when we have this relationship between nearsightedness and nightlights? The first one is that it could be A causes B, that nightlights do cause nearsightedness. That's certainly a possibility. However, it could also be the case that nearsighted children need nightlights to see at night. So B causes A, that being nearsighted causes someone to need a nightlight. It could also be that some unknown factor is responsible for both variables. For instance, nearsighted children probably have nearsighted parents who may need to leave nightlights on at night to see their children. And so the third factor of nearsighted parents causes both the nearsighted children and the nightlights to be on in the room. The thing to keep in mind is that all three possibilities are equally likely, but people erroneously only consider one possibility, that nightlights cause nearsightedness, and ignore the other two equally likely explanations. All right, let's do one more example. A study of 33 surgeons and surgical residents finds that those who had more experience playing video games did better at performing laparoscopic surgery on a simulation test. So here we have the correlation between two variables. What do the authors conclude? Well, the authors conclude that medical schools should consider including video games in their training. Essentially, that playing video games causes an increase in surgical performance. So again, it's the same idea as before. It is possible that video game playing improves surgery skills, but it's also possible that becoming a good surgeon improves people playing video games. And it's also possible that a third variable is responsible, that people who naturally have good eyesight are both good at video games and are likely to pursue a career that can take advantage of their eyesight as a surgeon. The reasoning error is people jump to the first explanation, that video game playing causes an improvement in surgery skills, when the other two explanations are equally likely. The next example of faulty reasoning is making faulty probability judgments, specifically that people are often poor at judging the true likelihood of an event occurring. So here's an example. Let's say you're at a party and there are 23 people, including you, in the room. Here's the question. What is the probability that there are 2 people in the room with the same birthday? So think about this for a second. 23 people in the room, what is the probability that 2 of them have the same birthday? The correct answer is 1 in 2, or 50%. And for a group of 75 people, there's now a 99.9% chance that 2 people in the room have the same birthday. But here's the point. When I asked you to come up with a number originally, I bet you were pretty far off from 50%. At least you were if you're like my students in my face-to-face class. So the point is that people are often poor at judging the true likelihood of an event occurring. This website shows why it's 50%, or you can just Google birthday 23 people, or you can trust me because I'm an expert. But the overall point is people are often bad at judging the true likelihood of something occurring, so if you conclude the probability of something occurring just by chance must be very small, keep in mind that that's not necessarily true. Next example of faulty reasoning is failing to consider regression to the mean. And regression to the mean is the phenomenon that, simply due to chance, extreme scores are likely to be closer to the mean when performance is retested. A great example of this is the Sports Illustrated Jinx/Madden curse. For those of you who don't know what it is, the idea is that an athlete on the cover does worse the week or season after they're on the cover versus the one before appearing on the cover. Maybe they become injured, or maybe they just don't perform as well. And so, apparently being on the cover jinxes them. But is there a better explanation? Well, let's consider this one. To get on the cover of Madden in the first place, you must have performed incredibly well the previous year. You had to have been one of the best players in the NFL. And so, next year, what's more likely? That you do as well or better than the previous year? Probably not. Or that you do a little worse or even become injured? Well, yes, statistically speaking, that's more likely, and that's regression to the mean. Simply due to chance, extreme scores are likely to be closer to the mean when performance is retested. Here's another quick example. If a runner gets a personal best time for a given distance, that person will likely get a slower time on his or her next run of that distance. So be careful in your reasoning that you don't create unnecessary explanations for regression to the mean. It's not that being on the cover of a video game or running at your personal best causes you to do worse the next time. But if you perform at your absolute peak ability for a season or a race, the next time are you more likely to perform even better or worse? Fifth example is making the post hoc ergo propter hoc error, which is stating that because something occurred after an event, that the event must have caused it. Post hoc ergo propter hoc means after this, therefore because of this. You see this faulty reasoning in politics a lot. Someone gets elected and something happens, therefore the event must have been caused by the person that got elected. So for example, President Bush was reelected and then the US economy crashed. Therefore, Bush was the one who caused it. Well, that's faulty reasoning. There were lots of reasons for the financial collapse of 2008, and probably the biggest one was the crash of the housing market. So, just because Bush was president at the time, it doesn't mean that he caused it. Or how about this? More and more young people are attending high schools and colleges today than ever before, yet there is more juvenile delinquency amongst the young. This makes it clear that these young people are being corrupted by their education. Well, no, that's faulty reasoning. Even if it is true that juvenile delinquency is on the rise, there are lots of differences in how children are raised nowadays compared to in the past that would explain why juvenile crime rates are higher, such as differences in their parents living in poverty or divorce rates. So, just because there might also be a difference in amount of education, that doesn't mean it is responsible. The last faulty reasoning error I'll mention is making the compared to what error, which is not realizing that the impressiveness of a large statistic can only be determined by comparing it to a baseline. So for instance, you might hear on the news that 85% of kids who eat cheese end up graduating from high school, with the implication being that you should feed your children cheese to increase their likelihood of graduating from high school. Now, that's great, but what do we need to know before deciding whether cheese actually does help kids graduate from high school? Well, we want to know what percent of kids who don't eat cheese end up graduating from high school. If the answer is 85%, then our original statistic, even though it's big, isn't that impressive, as a child's likelihood of graduating from high school is the same, 85%, regardless of whether they eat cheese or not. The point of this reasoning error is that a lot of people see that large number, 85%, and conclude that yes, cheese must make their kids smart, but they don't stop to think about what they should be comparing that number to. Here's one last example. People are often impressed when they hear that something like 30% of supposedly infertile couples who adopt a child eventually conceive one of their own. This might be interpreted to suggest that looking after a child somehow causes the parents to overcome their fertility problems. But what's the problem, or what information is lacking? Well, we don't have a baseline for how many supposedly infertile couples who don't adopt eventually conceive a child. It might be 30%, in which case adopting a child has no effect on a couple's fertility. Or it might be less than 30% or greater than 30%. But without the baseline, we can't determine how impressive the original statistic is. The last kind of evidence that we need to discuss is personal empirical evidence, which is evidence based on one's own observations and experiences. Essentially, empirical evidence is about using our own experiences to gather evidence. For example, if you heard about an accurate psychic who can supposedly speak with the dead, maybe you go and see her for yourself rather than relying on your friend's anecdotal account. Or maybe you go to the mall one day and observe people's behaviors to try to learn about how people act differently when they are in a group versus when they're alone. So empirical evidence refers to evidence gathered from your own experiences or own empirical observations. The main strength of empirical evidence is that it's generally a good way of testing and acquiring new information, as it avoids many of the weaknesses of the other types of evidence. So yes, it's a good way of examining the world. For instance, it avoids many problems with anecdotal evidence because instead of relying on other people's experiences or reports, which might be wrong, you are relying on your own. The same thing is true with evidence from authority or common sense evidence. You're not relying on what other people say or believe, but you can find things out for yourself. And we find this kind of evidence to be very convincing. You often hear people say that I didn't believe in psychics or I didn't believe in this new treatment until I experienced it myself. The main weakness with empirical evidence is that we only experience a small amount of the world and we may overgeneralize from these experiences. The idea is each of us only gets to experience a small part of reality, and so what we conclude based on our experiences is often biased or not true of the whole. If you work on a college campus, your experience with a certain minority group, let's say Asians, is probably that you think that young Asian males are smart, polite, and academically gifted. If you're a police officer, on the other hand, that works at a task force that targets Asian gangs, your experiences with young Asian males is probably a lot different. So, it's not that one person is necessarily right or wrong about their opinions of young Asian males, but people with different experiences will draw different conclusions. So, that's one problem with this type of evidence. Another weakness is that we often rely on this evidence the most in situations where it's most likely to be faulty. For instance, for paranormal events like the existence of ghosts, your personal experiences may be the primary type of evidence you base your beliefs on, and it would be very convincing. I experienced an odd sound or heard something that sounded like human speech in a supposedly haunted house, so it must have been a ghost. Or you might have gone to a psychic and afterwards remembered a number of statements that she made about you which turned out to be true. But as we'll see, these are the situations where errors in empirical evidence, either in perception or memory, are most likely to occur. So along those lines then, we're going to begin by talking about some reasons to mistrust our perceptions, and then we'll discuss some reasons to mistrust our memories. So first, reasons to mistrust our perceptions. One reason is that perceptual constancies and illusions show that we have certain perceptual experiences regardless of input from our senses. If you take a class like Sensation and Perception, you'll see a lot of examples, but let me just give you a couple examples of some visual illusions. In this first example, the question is, are these two indicated squares the same color? Are the two squares the same shade of gray? It looks like they aren't, but if I get rid of some of this interference without doing anything to the squares, you can see that yes, they actually are the same color. What happens is that your visual system leads you to see the square in the middle as being lighter than the one on the outside to compensate for the fact that the square in the middle would look a little darker because it's in a shadow. So it doesn't matter that it's actually the same shade of gray, you perceive it in a certain way regardless of what's in the environment. Another example is called the autokinetic effect. In studies, people are asked to stare at a white light in a completely dark room, and they're asked to respond when they see the light move. Many people eventually see the dot move, however, it never actually does. The obvious implication of this effect is that someone who stares up at a bright star or Venus on a clear night might perceive that it's moving when it really isn't, and mistake it for a moving UFO. Another reason to mistrust our perceptions is the role of expectancy, that people often perceive what they expect to perceive, especially when the sensory information is unclear or ambiguous. There have been studies where subjects were told to walk along a corridor until they saw a light flash. Some of the participants stopped, despite the fact that no flash was ever presented. In other studies, participants experienced electric shocks, felt warmer, or smelled odors, despite the fact nothing was ever presented. Instead, they feel or see these things because they expect to. So, it's not surprising that someone who expects to feel colder when walking through a supposedly haunted house might end up feeling cold, or they might mistake a random sound for human speech. So again, expectations are going to be particularly influential when the stimulus is vague or when clear perception is difficult. A final reason to mistrust our perceptions is something called pareidolia, the tendency to see familiar patterns in ambiguous stimuli. Here's a famous photo of a mountain ridge on Mars, photographed by Viking 1 in 1976. Many people reported seeing a human face in this photo, and they took this as evidence that a monument to humankind appears on Mars, and hence there must be intelligent life on Mars. But why do we perceive a human face in this photo? Well, it's because we spend our whole life looking at human faces, and so our brain interprets its ambiguous information to make it look like a human face. To put this claim to rest that there is intelligent life on Mars that makes statues to humans, you can see this picture that was taken by the Mars Global Surveyor in 1998, and to see that it's just a random mountain range and not a face. Other examples of pareidolia include seeing the Virgin Mary in a grilled cheese sandwich, as some people have found. And finally, let's discuss some factors that influence memory. One thing that distorts memory is source monitoring errors, which is not being able to remember or misremembering the origin of a memory. So even if the memory itself is accurate, we sometimes forget the source of that memory. For instance, during a presidential campaign, Ronald Reagan told a moving story he heard from a World War II pilot who ordered his crew to bail out of their damaged airplane. The gunner was injured and couldn't jump, though, and so the pilot promised heroically, "Never mind, we'll write it down together." The issue is that this story didn't come from a real pilot. It was actually from a movie called A Wing and a Prayer. So while the memory about the event was accurate, the source of the memory was not accurate. Reagan remembered the stories coming from a person when it instead came from a movie. The implication of this effect is that if you heard about a treatment being effective or that some psychic is accurate, it might not matter if you originally heard that information from a credible source. You might forget the source, and just being told the information can lead you to accept it as true. This is probably how many of our 50 myths and false common sense beliefs get spread. People hear something repeated so often that they just come to accept it as true without remembering that the source of the information was faulty. And then finally, familiarity, suggestions, experiences, and expectations can all bias memories. So if you believe something is true, you'll often misremember events to support your beliefs. In the 1960s, for instance, researchers showed participants a picture like this one. It displayed a white man talking to a black man, but in the white man's hand was a straight-edged razor. When participants recalled the picture from memory, however, half of them erroneously recalled that the razor was in the hands of the black man and not the white man. This demonstrates that memory is affected or reconstructed based on our expectations and beliefs. In this case, that people in the 1960s believed that black men are dangerous and carry weapons. So, the point is to be wary about believing the accuracy of memories that might be distorted by these sorts of biases. All right, that's all I have for you today.